A body mass is accelerated from the state of rest in constant gravitational field, gravitational force mg, that perform a linear motion, applying the coordinate system in the way the x-axis indicates the direction of motion and solving the corresponding one-dimensional equation of motion. mt square ht over dt square equals to mg. For initial condition, we obtain h0 equals to 0. dh0 over dt equals to 0. The coordinate h as a function of time ht equals to 1 over 2 gt square. The h is directly proportional to the square of time. This can be displayed by representation of ht square from the regression line of the data. The gravitational acceleration can calculate because the slope is equal to 1 over 2g according to the equation. From this experiment was doing to investigate the functional relationship between rate of fall and falling time. Other than that, it was to determine the acceleration due to gravity by studying the motion of freely falling body.
Okay, this is the apparatus that we use in our experiment. First, wooden ruler 1 meter, ping pong ball and stopwatch in our phone. Okay, next we move to procedure. First, the apparatus as in figure 3.1 was set up. Second, the height of fall from 0.6 meter until 2.4 meter were measured and were marked. Third, the ball were released at a different height and the time taken for the ball to reach the floor were recorded. Next, every height of fall were repeated 3 times at the same height of fall. Last, all the data were recorded in a suitable table. Okay, so this is how we do it.
This is the result from the experiment that we do in the lab. We use the difference height of fall and repeat 3 times each height to get an average of time.
The next part is analysis. Number 1. From the data, plot graph for A. Height of fall as a function of falling time. B. Height of fall as a function of the square of falling time. Number 2. Using the height of fall as a function of the square of falling time graph, determine the gradient of the graph and calculate the value of g. Firstly, we take the equation of h equal to 1 over 2 gt square equal with the equation of y equal to mx plus c. So we find the value of g by take the two coordinate from the graph. Next, number 3, calculate the value of uncertainties of g. First, we find the minimum line and maximum line. After that, we find the two coordinate of each line and we use the formula of uncertainty to find the uncertainty for g. Analysis 4. Calculate the percent difference between the value of g calculated in part 1 above the experiment and the standard value of g is equal to 9.81 meter per second square. What is the percent error in this experimental value? By using the formula of percentage difference and percentage error, we can get the answer. Next, is there any experimental errors? Discuss. Yes, it is because all experimental data is imperfect, so random errors are uncontrollable. The precision and accuracy of the data values was slightly off, thus it caused uncertainty. Therefore, all the data must go through a careful calculation to reduce uncertainty. And the next part is discussion.
Okay, lastly, we move to the conclusion. The conclusion of the experiment of measuring gravitational acceleration is functional relationship between height of fall and falling time is directly proportional because when the height of fall are increased, the falling time to the ball reach the floor also will increase. Next, the acceleration due to gravity are constant, which is 9.1 meter per meter square. So, an improvement that we can make for this lab is stop the stopwatch immediately when the ball reaches the floor to get the exact value of the falling time taken. So, this is our reference. That's all from us. Thank you.